Welcome to the HD tutorial. Myself Harshal sir. I am MSc Electronics NetSet qualified and the PhD pursuing. Today we will be going to discuss the types of the component. There are the two kinds of the component. One is known as the active component, another one is known as a passive component. In the electronic we always deals with the voltage and current. In this case, those component who enhance this electrical parameter is known as the active component, and those does not enhance this electrical parameter is known as the passive component. So what is the example of active component? All the semiconductor component is belongs to the active component. So which are the active component? For example, it is the diode, led stand for light emitting diode, then the transistor, MOSFET. These all are the active component. What about the passive component? The component who does not enhance this electrical parameter like a current and voltage, for example the resistor, capacitor, inductor, fuse, battery, switches, these all are belong to the passive component. Now the first one component is resistor. What about the resistor? A resistor is a passive component who ability to limit the flow of the current. Their unit is ohm. The circuit symbol of the ohm is look like in this way. It is denoted by R. Their unit is ohm, and the ohm is denoted by like that way. Okay. Now this is the one of the example of hydraulic analogy of the electrical resistance. Now as shown in this diagram, the water flow from the one end to the another one end. If in case the water pipe have some resistance, then the flow of water is get resist. Now look like in this way. Here the water flow from the one end to the another end. The water is flowing freely from one to another place of the terminal. Now if the pipe is get some uh, press, if we press this pipe, or in this pipe the water flow from one end to the another end is get limited due to that some resistance or the some barrier. Okay, similar way, if we observe, if we take the another one example about the how to understand the resistance. If the person is a present, he having the one vehicle, and the vehicle is a traveling through the road, a road having a resistance. This is the R1, this is the R2, and this is the R3. Now in this case, this is R2 and this is R3. The vehicle is flowing in this way. Okay, when he will be reach at the R1, he getting the small amount of resistance. That means the vehicle speed is get limit. Their speed is getting limit due to this one resistance. If he reach at the R2, again the speed is again limited too much as compared to the R1. And when he will be reach at the R3, the vehicle is completely stopped due to this large amount of the resistance. Okay, so George Siemens Ohm, he was invented the Ohm's law in 1827. So what is the relationship between the current and voltage? This will be understand by using this basic electrical circuit. What about the basic electrical circuit? In this case, the voltage and the battery supply is provided by using this multi storage battery. The current is flowing into the I and the resistance is R. Now the potential difference across this resistor V is directly proportional to the current flowing into there. So proportionality constant is equal to what? It is the resistance R, and this is the I. If this I is moving at that place, so we can easily calculate the resistance R is equal to V divided by I. So according to this formula, the ohms is derived the two relationship. So which are they? If here the resistance is directly proportional with the potential V, that means the resistance is going on increasing, the potential is also going on increases, and resistance is inversely proportional to the current. That means if the resistance is increases, then the current is going on decreasing. Similar way, if the resistance is if the resistance is going on decreasing, then the current is going on increases. That is the inversely proportionalship relation of this resistor and current. Okay, now another one example, if the voltage is the 2 volt and the current is 4 ampere, how much amount of the resistance resistance R is equal to what? According to the Ohm's law, V divided by I have what? I have the voltage. So voltage is 2 volt and the resistance is 4 ampere. This 1 divided by 4, it is the 1 by 2. If we calculate this, it is the point 0.5. Point 0.5 is what? It is ohm. That means 0.5 ohm resistance is offering by this resistor. Okay, now this is the example how to implement the resistance or the use of the resistance in this application. So all of you know that this is the LED and this is your battery. Battery is 9 volt. Here the negative of the battery is connected to the negative of the diode, your LED. Similar way, positive terminal is get left open. Now here we want to provide the current is only 30 milliampere. So we want to put the one resistor to protect this LED. If we are not putting the resistor to protect this LED, so the large amount of current is flowing into the your LED and LEDs get damaged. So that's why we want to find out the resistance value to protect this LED. How to find out? V is equal to what? I into R. This is the Ohm's law. We know about that voltage. We have a voltage and the current. So the resistance value R is equal to what? V divided by I. V is 9 volt. Current is 30 milliampere. 30 milliampere means 30 into 10 raised to minus 3. So it is divided by 3. It is 3. It is the 10. It is the 10 raised to minus 3 and it is 10 raised to plus 1. If the base is get same, then addition or the subtraction it will be takes place. 3 divided by 10 raised to 1 multiply by 10 raised to minus 3. Then our answer is 10 3 divided by 10 into 10 raised to minus 2. If this 10 raised to minus 2 is going on above, then value is 3 into 10 raised to plus 2. Plus 2 means what? Our resistance value is 300 ohm. If we put the 300 ohm resistance here, then our LED is glowing. If is disconnect, then LEDs get off. If the LED is connected, then LED is glowing. So this is the protected amount of the resistance value to protect our LED. So this is the application of the resistor. But the different kinds of resistor is available in the market. So which are they? The first one is the fixed value resistor, another one is a variable resistor. The fixed value resistor is look like in such way that it is the carbon type of composition. Okay, here the resistor they don't have provided any kind of the polarity. Another one application is the variable resistor. The variable resistor, it is the potentiometer, rheostat and the trimmer. The potentiometer is as shown in this diagram. A potentiometer is useful to increase and decrease the volume of the TV. Similar way, the rheostat is useful in the laboratory purpose. A trimmer is useful in the motherboard circuit. Okay, according to the physical quantity, these are the some types. One is known as the thermistor, another one is the LDR, and third one is the strain gauge. What about the thermistor? In the thermistor, when the temperature is get increases, the resistance value is also increasing. Such type of component is known as a positive temperature coefficient. If the temperature is going on increases, then the resistance is going on decreasing. This is known as the negative temperature coefficient. Another one example, the dependent on the physical quantity, it is the LDR. LDR stands for the light dependent resistor. Our LDR light dependent resistor is look like in such way that in this case when the light fall into the LDR, the resistance value either it is increases or either it is decreases. If it is increases, it is useful in the automatic street lights. For example, if the street light is present here, if the street light is present here, when the sun is present, the resistance of the LDR, when the sun, that means light intensity is increases, then resistance is also increasing. That means the current is not flowing into there, the resistance is stuck. Sorry, resistance is not stuck, the current is get stuck. The current is get stuck. Okay, now what happened in the another way, another application? If the light intensity is increases and the resistance value is going on decreasing, where it is used such type of LDR, it is useful in wall watch. What happened in the daytime? In the daytime when the sun is present, when the sun is present, okay, If the sun is present in this case, okay, if the sun is present, then what happen? Our wall watch is not given the toll. Is it when the sun is present, the wall watch is giving the toll, okay? And when at the night time the light is not falling to the LDR, the resistance value is going on increases. If the resistance value is going on increases, our wall clock is not providing any kind of the toll. So this is the application of the LDR in the different place. So all of you getting the types of the resistor. Resistor are the basically two type. One is known as the fixed resistor. Their value is value is not changed. Some of the resistor is useful to change the value. For example, it is a potentiometer, rheostat, and the trimmer is there. Okay, according to the physical quantity, these are the three type. One is the thermistor, another one is the LDR, another one is the strain gauge. Okay, this is the circuit symbol of the resistor. This is the fixed value resistor circuit symbol. It is the variable potentiometer circuit symbol, or it is useful in the potentiometer and the rheostat. And the third one is the preset, and the last one is the preset. Okay, now this is the color code system about the resistor. In the color code system of a resistor, there are the three type. First one is the four color band system, another one is the five color band system, and the last one is the six color band system. A resistor is a very small component. We cannot print the value of the resistance, so that's why the color code system is used to identify the resistance value. In the four color band system, the starting two color, first and second, is act as digit. Third one is act as multiplier, and the fourth one is act as a tolerance. My one of the student Anurag, he have done this chart. In this chart, the first one is the color code. What are the color codes? It is the BB Roy, Great Britain, very good, gold, silver, white, gold, and silver. Okay, so here the first one is, it is the number, second one is the multiplier, and the third one is the tolerance. According to our principle, the starting two color is act as digit. Okay, so digit is present here, third one is the multiplier, and the fourth one is the tolerance. So see the one by one example. If the resistor is a present, this is the carbon composition type of the resistor. Here you are always gold and silver in your right hand side. On the left hand side, this is the actor's first color, this is the second, the third, and this is the fourth one color. So it is the same way. According to the principle, first two colors act as digit, third one is multiplier, fourth one is the tolerance. Okay, so let us see the one by one the example. Now in this case, here it is the gold, here it is the red, this is the black, and this is the brown. Okay, it is the 1, 2, 3, and the 4. This is the color code system. Starting two color is act as digit. The first one is brown, so the brown is indicate 1. Black is indicate 0. Black is indicate 0. Okay, third one color is act as multiplier. What about the multiplier of the red? Red, it is the 10 raised to 2. 10 raised to 2. And gold and silver, their tolerance is plus minus 5%. So what is about the resistance value? 10 raised to 10 into 10 raised to 2 means it is 20 plus minus 5%. So what about the resistance value? It is 1000 ohm. 1000 ohm, and tolerance is plus minus 5%. So what about the resistance value of this? It is the 1 kilo ohm, and resistance tolerance is a plus minus 5%. Now take another one example. Now in this resistor, it is the orange orange, and this is the gold. Okay, so orange 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 and gold. Starting to color is act as digit, third one is multiplier, fourth one is the tolerance. Okay, what about the orange? It is the 3. Okay, this is also 3. Third one is the multiplier of orange is 10 raised to plus 3. And tolerance of the gold, what about this gold tolerance? This is the 5 plus minus 5%. Okay, So it is 10 raised to 3, it is a kilo ohm. It is a kilo ohm. That means there is a 33 kilo ohm, and the tolerance is plus minus 5%. Okay, now another one example as shown in this diagram. The first one is the brown, second one is the black, third one is the orange, and the fourth one is the gold. Okay, according to our principle, the starting two color is active digit. First, second, third one is multiplier, fourth one is the tolerance. Starting two color, it is what? It is the brown is what? It is 1. Black is 0. Orange, their multiplier is the 10 raised to 3. And tolerance of the gold is a plus minus 5%. What is the answer? It is the 10. 10 raised to 3 means it is a kilo ohm. Tolerance is plus minus 5%. The resistance value is 10 kilo ohm. The resistance value is 10 kilo ohm. This is in the simple way we can calculate the resistance value using the color code system. Okay, thank you all of you. If any difficulty, you make a comment on my chat box. Okay.